when discussing this comes under geometric nonlinearity. If all the members are linear and behaves linearly, then P delta effect is not required. Practically, if you are wanting to know nonlinear behavior after the elastic stage, how the member behaves, generally in tall structures within elastic limits, you can study P delta effect. When you are constructing any structure and if you are having a large height when comparing to the cross section, what happens if you provide the dead load and live load, the structure deflects due to the self weight and an additional load which is being added laterally. So you have two number of loads. What are they? One is vertical load due to gravity and second one is horizontal load due to wind or earthquake. So when two number of forces acting simultaneously, what happens? A moment is being generated and this is called a secondary effect, and this secondary effect is called P delta analysis. If we want to analyze in elastic stage, we can analyze for tall structures, and if we want to do for nonlinear analysis, you can do for whatever stage it might be. And for G+1 building, you can find non-linearity, how it gets collapsed. To study the collapse load and collapse behavior, the P delta analysis is very much useful. What do you mean by P is force, delta is known as deflection, P delta is force and deflection effect. The vertical load is not acting to its centroid, then P delta effect will get. From this definition, you can understand that the P delta effect are large displacement and rotation effect. When you have large displacement in a structure and rotations, you will be having P delta effects. Okay, now let us understand this. When the construction is being done, if you are building a column, it will be assumed as 90 degree with respect to the ground. But during construction, there will be out of plumb effect. So your plumb will not be exactly perfect from the zero story to the top story. You will be having some non-linearity in the construction. What happens? This creates additional moment to the structure, additional force to the structure. This is called geometric nonlinearity. Okay. Geometric nonlinearity can be considered on a step-by-step basis in nonlinear static and direct integration time history analysis. You can either do nonlinear static or direct integration, that is time history analysis, and incorporate in stiffness matrix for linear analysis. You will be adding in terms of stiffness matrix. Now, when the load acting on a structure and resulting deflections are small enough, then the structure is termed to be as linear. Strictly speaking, equilibrium equation should actually refer to geometry of the structure after deformation. You imagine a column which is having a load of 40 kg and you imagine a column which is having a load of 0 kg. Let the column be a cantilever column and there is no weight at the top, and the second case you are having 40 kg of weight. So what happens when providing 40 kg of weight, column will get buckled and there will be slight deflection. So generally we are building number of stories, 10 number of stories or 5 number of stories. What happens? All the stories you have floor load, and at the floor load you will be having dead weight. At each and every floor you will be having a dead weight. Column is a cantilever beam which is fixed at ground and it is free at top. All the column are having only one type of support which is fixed at one end, free at another end. So if you are keep on adding the load in the floors, what happens? This column tends to deflect, and under the deflected manner you are applying the load and you are applying live load, dead load. We are bringing masses to the structure. So due to this, there will be a moment. This moment is called P delta effect. When you are keep on adding your floors, what happens? The column will be getting deflected, and in that deflected member you are still adding the floors and still adding the column. So all the members are not practically under equilibrium and the geometry is not straight. Now when looking into this, for small stories it is negligible, and you can see when we are analyzing, I will show you that how much negligible when you are making a small structure, but when you are going for large structure and tall structure, this P delta effect will be here in magnitude, comparable and accountable. If the load in the structure and or the resulting deflections are large, then load deflection behavior may become nonlinear. If you are having large deflection, then the structure will be nonlinear in geometry. Several causes of this nonlinear behavior can be identified. This can be identified by this P delta effect. Okay, in code book, in IS 1893, it is a secondary effect on shear force and bending moment. Apart from shear force, apart from bending moment, you have an effect called P delta effect. This will only be applicable for large deflection structures. It can be also used for some cable structures such as suspension bridges, cable stayed bridge and guide towers. For these kind of analysis, definitely we need delta analysis. Now you have material nonlinearity. First thing which I have discussed is geometric nonlinearity. Second thing is material nonlinearity. If you have two material and wanting to know the secondary effect, then P delta analysis could be found. Okay. Now let us go to our model. Then let us find the P delta effect. So let me go to the 3D. This is our structure. How to introduce P delta effect? What you can do is define. Here you have P delta options. You click here, you will be getting three options. First one is none, second one is iterative, and third one is iterative based on loads. So it is better to go for the third case, it will give accurate answer. Now you can add dead load, live load of 0.5 percentage, earthquake load in X and Y direction. So dead load will be acting vertically downward, live load will be acting vertically downward towards gravity, and earthquake will be occurring at either X and Y direction. So you need two number of forces in order to get some P delta answer. So let us check the analysis. Relative convergent tolerances. The iteration will get automatically stopped when both the values are 0.001 accuracy. Up to that accuracy, the iteration P delta analysis is an iterative process. If you are doing manually, you will be knowing that. When to stop that process is if both the values are 0.001, then the iteration gets stopped. Now let us find the P delta for our structure and let us apply this. This is present and press OK. Now if you are doing the analysis, before P delta analysis, let us check the model. So first let me show you, I have applied P delta here, P delta option, and I have given. Let us first check what is the answer for P delta analysis. There is no complicated steps are here. If you are just applying the P delta effect and what are the loads, lateral loads which you are going to consider, that is enough for making the P delta effect. And you can see that there is analysis running here, and in that it will automatically include P delta effect. You can see here P delta 0%, 0 case. When we have included P delta effect, it will calculate for the P delta analysis. Up to 100% it is going to take. Then earthquake, time history, all the analysis it is going to be done here. Now our analysis is over. Let us check the base reaction here. Let us check response spectral phase reaction. Now these are our reactions. You can see that we are having moment of 0.0, 0.0, F1 as 1.31. Let us take this as a snapshot and let us introduce here. We have included in this slide here, we got 0.4539 as the first value, 0.4539, you can see 0.4951, all the values which I have taken a snapshot here and I have kept here. Now for the next set of column, for these columns you have the rest of the values. This is 2.3181, 2.3181. I have provided the values here and I have taken a snapshot. These are all P delta analysis. For reference, let me write P delta analysis. Let me write P delta. This is also P delta. We have got our values at both the sides. We have only got the base reaction. Okay, let us check the analysis without P delta effect. For response spectrum, what case we are checking? We are checking for response spectrum and we have applied, we have got this reaction. Now let us open this model and let us eliminate the P delta effect. Let us go here and press none. No P delta analysis is required as of now. Now just I am running the analysis. Without P delta, it is going to check right now. When you check here the status bar during analysis, it is not going to check the P delta case now. You can see here it is starting from earthquake load. Previously it has calculated for P delta effect, but currently it has not calculated for P delta effect. Now we have done for response spectrum, P delta for response spectrum. Response spectrum. This is one case. Let me copy this. Response spectra. Okay. Now let us check for ordinary frame. The analysis is over and let us check the base reaction. For same response spectra, our load case, we are checking the base reaction. Now let us take a snapshot here. Let me introduce now. You can check here that the value in the bottom story without P delta is 2.2395 and with P delta 2.4. You can see it is 2.24 at this value. Here you are getting 2.23. The small deviations you are getting. Both the things are for response spectra. You can see the load case is response spectra here. Here also response spectra case only. Now you can check here that the values are without P delta. Now let me write here without P delta. No P delta. Let me just simply write no P delta and let me give some highlight. I am highlighting in red color. If you are not considering P delta, you can see the load is reduced 1.8099 as your Fx, and if you consider 1.8067, if you consider the P delta effect, it is 1.8067 and moment 2.2135, 2.2087. The moment is much lesser here, 2.21 and 2.2807. Why the deviations are very much less is since you are having D+1 story, the moment is also reduced. This is without P delta effect. Response spectra for no P delta. You can check here that without P delta effect you have 0.4537, 0.4539. So this is the accuracy of change. So you will be having much lesser value. For higher stories, you will be getting a considerable value and considerable effect due to this. Support reactions, just now we have found that if we are going into load combinations, you will be getting much good clarity. We can check the similar way how the P delta effect works.